In this video, we will discuss about combination of the resistors. We are having two types of the combination of the resistors. First one is the series combination of the resistors and second one is what? Parallel combination of the resistors. We already studied series combination of the resistors. You can observe that lecture. Now in this class we will discuss about parallel combination of resistors. Observe, this is what? Parallel circuit in which R1, R2 and R3 are three resistors and they are connected parallel, and dropage across these all resistors is what? V. For this resistor and for this one, voltage drop will be what? This source, and current I is flowing from this source, I flowing, and this current I dividing in three branches. At the node A, this current I is dividing into I1, I2, I3 in three branches. This current is dividing. Clear? So in the parallel circuit current is not same in each branch. Observe, this is a parallel. R1, R2, R3 are parallel. Why? Because voltage dropage, voltage across each element is what? Same. If voltage is same, then we can say they are connected in the parallel. But current is not same. In this branch, current is I1, in which I2, and in which branch what? I3 current is following. Why? Because this current is dividing at A. Clear? So we want to find the equivalent resistance for the parallel resistors. How we will find if these three resistors are connected in parallel, then what will be the equivalent resistance we want? So in our syllabus we studied, we are having one topic. What topic? Kirchhoff's law, and that law is very useful to find the equivalent resistance of series combination of the resistor and parallel combination of the resistor. In the series combination of the resistor, we used what? Kirchhoff's voltage law. Why? Because in the series combination we are having three resistors are connected in the series, and that is the closed circuit and closed loop. We will use what? Kirchhoff's voltage law. But in which we are having parallel resistors and current is dividing, and once current is dividing, it means we will use Kirchhoff's not voltage law, Kirchhoff's current law. And what about the Kirchhoff's current law? Observe, from KCL, what is the KCL? Kirchhoff's current law. This is Kirchhoff's law. And what is this one? Observe, at the node, what is the Kirchhoff's current law? At the node, two or three more branches are intersecting. That is what? Node or junction. Node is what? Where two or three more branches are intersecting. So one is this branch, and what is the branch? What is the branch? Branch having elements. Clear? Branch is what? Having elements. So this branch, and this branch, these four branches are intersecting at A. So this is what? Junction. So at the junction, incoming current must be equal to outgoing current. That is what? Kirchhoff's current law. What? From Kirchhoff's current law at node A, this is node A, at the node, incoming current must be equal to outgoing current. So this node, at this node, current I is coming, and I1, I2 and I3 are outgoing current. So we can say incoming current I must be equal to what? Outgoing current, sum of the outgoing current. Summation of I incoming must be equal to summation of I outgoing. Incoming current must be equal to outgoing current at the node or junction will be what? Kirchhoff's current law. So by using Kirchhoff's current law, we can find the equivalent resistance of the parallel combination of the resistors. Clear? Observe carefully. So we are using this Kirchhoff's current law there, but in which we are having current I. We know well in the parallel circuit current will be what? Different, but voltage will be same for this element and this element. Voltage will be what? V, same. Clear? Current will be different. So we are having one law, Ohm's law. We studied already, V equal to IR. From this law we can say I equal to voltage upon resistance. Why? Because voltage is the same but resistance value is different. R1, R2, R3 will be the different 2 ohm, 3 ohm, 5 ohm. So finally current value will be the different. So this is the general I value. I will be what? Incoming current. So this value will be this one. Apply for the R1, R2, R3. This I1 will be what? Total source upon this source upon R1. I2 will be what? This source upon R2, and I3 will be what? I3 current is flowing in this resistor. So I3 equal to what? V upon R3. So how we are getting I1, I2, I3? We can find from this circuit. I1 will be total source, total voltage V upon R1, V upon R2, V upon R3. So V upon R1 will be I1, V upon R2 will be I2, V upon R3 will be I3. So in the parallel circuit, current will be the different, but voltage at each element will be what? Same. Clear? In the parallel circuit. So from the Ohm's law we obtained I1, I2 and I3 values. We will put these values, putting the values of I1, I2 and I3 in equation number 1. And equation number 1, how it is coming? It is coming from the Kirchhoff's current law at node A. And how we will apply Kirchhoff's current law? Kirchhoff's current law. What is this one? At the node, incoming current must be equal to outgoing current. Incoming means I current is coming to this node, and I1, I2, I3 are going from this node. So one side we are writing incoming current and other side we are writing what? Outgoing current. And this will be what? Kirchhoff's current law. And node and junction will be what? Two or more branches intersecting a point. That point will be called what? Node or junction. Clear? Finally we are using these values and putting these values where? In this equation. Then what we are getting? I equal to V upon R1, I1, I2, I3 are what? These values. We are putting, solving. V is common in all, so we are taking outside. Now solve. V2 V will be cancelled. V2 V will be cancelled. So 1 upon R equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So where R1, R2, R3 are the three resistors are connected in the what? Parallel. Then R will be what? Equivalent resistance. Once we solve by taking LCM and solve, then we are getting the value of R, and that R is called what? Equivalent resistance. If n resistors are connected, in parallel, then what will be the equivalent resistance? Like if n resistors, like in which we are having three resistors are connected in the parallel, and if we are having more than 3, 4, 5, 10, like nth resistors are connected in the parallel, then equivalent resistance will be what? 1 upon R equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus 1 upon R4 plus so on, like this. If 5, then we will write 5. If we are having 10 resistors, then we will write till 10 resistors. And solve for this what? R. And R will be what? Equivalent resistance. So this is the process of finding the equivalent resistance. I am having small concept there. If two resistors are connected in the parallel, R1 and R2 are resistors and they are connected in parallel. Why they are in the parallel? Why? Because in which current I is flowing this point, and after this one current is going to be divided. Current values are different. R1 and R2 are having different currents. But dropage across these elements will be what? Same. Dropage same, then we can say parallel. R1 and R2 are in parallel. If current same, then we can say what? Series circuit. So both resistors are in parallel, then what will be the equivalent resistance? How we will solve? 1 upon R equal to 1 upon R1 plus 1 upon R2. 2, only we will stop this one. We cannot write this one, only this one. And solve this one. Taking LCM is what? R1 into R2. R1 R2 divided of R1, R2 is remaining, so R2 will be multiplied by 1, R2 this divided of this one, R1 is remaining will be multiplied by numerator, then we are getting this one. So we can say once we do cross multiplication and solving for the R, then finally we are getting equivalent resistance. R will be what? Product of both resistance divided of the sum of the both resistance. Once two resistors are connected in the parallel, then directly we can find the equivalent resistance. That will be what? Product of both resistance divided of sum of both resistance will be what? Equivalent resistance value. Clear? So I hope you understand these all things. What topic we are discussing? We are discussing about the parallel combination of the resistors. We are having three resistors, they are connected in the parallel. Then once we are getting parallel, then current will be the different, but voltage source will be the same. Then we will use at the node, this will be the node, and we will apply the KCL there, and Kirchhoff's current law. KCL is what? Kirchhoff's current law, and this is what? At the node, incoming current must be equal to outgoing current. What is the KCL? At the node, summation of I incoming must be equal to summation of I outgoing. At the node, incoming current must be equal to, at the node, sum of the incoming current must be equal to sum of the outgoing current, and this will be what? KCL. We are using this node. I is coming, I1, I2, I3 are outgoing currents. We are writing. Then we will use Ohm's law, solving for I current, and the I is what? Voltage to resistance ratio. Then finally we are applying this one for the I1, I2, I3. We are getting this. So we are having I1, I2, I3. We are putting these values in this equation. We are solving, then we are getting equivalent resistance value for the series, so not series, parallel circuit. Once three resistors are connected in the parallel, then what will be the equivalent resistance? This one, 1 upon R. This R is what? Equivalent resistance. Once we solve, we will solve for the R, then we are getting the equivalent resistance. And resistance are connected, then this will be the formula. If two are there, then what will be the equivalent resistance? Product of both resistance. Two resistors are connected in the parallel, then what will be the equivalent resistance? Product of both resistance divided of sum of both resistance will be what? Equivalent resistance for two parallel resistance. Once two parallel resistors are connected, two resistors are connected in the what? Parallel. That's all about combination of the parallel resistance. Thank you so much.